Morning everyone. Welcome to another session of structural analysis. So far we have completed many problems on continuous beams. Along with that we have taken frames also, isn't it? Now today we'll take up one problem related to sway. What do you mean by sway? Have you ever heard the meaning of sway? Sway. I'll write here sway analysis. So the meaning of sway is when there is unsymmetrical loading on frame, then there will be sway in the frame. In the previous problem, we have taken up one frame wherein we have done analysis on a symmetric frame. We were having only one load here and one load at this point, and both the loads were 20 and 20, isn't it? You remember? Yes, the same problem. In the previous problem we have taken up this type of frame. So this frame is your symmetric frame. The meaning of symmetric is the loading on the left side of the frame and loading on the right side of the frame is same. Both of them, both the loadings and even the sections. This is I, right? I, if it is not given, we have taken I, right? And support conditions are also same. So depending upon that, the entire frame is sway. But when there is difference or when the frame is unsymmetric, the entire frame will go in sway. So the very first condition is unsymmetrical loading. Suppose for example, I have a frame like this. This is your frame. Both the end conditions are same. Okay. This is also I. This is also I. This is 4 meters for example. This is also 4 meters and this is also 4 meter or 3 meter. So the entire frame is, the dimensions of the frame is same, but if there is unsymmetrical loading. What do you mean by unsymmetrical loading? Suppose for example, I have a load of 20 kilonewton here and 10 kilonewton here, then this frame is subjected to unsymmetrical loading, and because of this unsymmetrical loading, my frame will try to sway. Can you tell me in which direction this frame will sway? See, we have 10 kilonewtons acting in left direction, whereas we have 20 kilonewton acting in right side, positive x direction. So because of this extra 10 kilonewton, what will happen? The entire frame will try to sway in this direction, isn't it? All of you agree with this? This is how the frame will sway. Okay, right? So this is nothing but your unsymmetrical loading, and because of the unsymmetrical loading will be the frame will experience sway. Okay, sway means moving from one point to another point. Another condition is, one more example for this one is, suppose we have the same frame again. Same frame, all the things, all dimensions are same, but we have a point load of 30 kilonewton like this. Even though we have here 20 and 20 kilonewtons. Okay. Now you tell me what will happen to the frame? Again it is subjected to unsymmetrical loading, and because of this unsymmetrical loading, the frame will try to sway in any of the direction because the loading is not symmetric. Suppose we have one more 30 kilonewton here. This is 2 meter and this is also 2 meter. Then this frame is symmetric. Otherwise, if I remove this load, the entire frame is subjected to unsymmetrical loading. Able to follow? Right. Another condition is different end conditions. Now what do you mean by different end conditions? See here I have a fixed support here, and at this point if I have a hinge support, then unsymmetric. The frame is said to be your unsymmetric, isn't it? The frame will subject to sway. The frame will experience sway once we have different end conditions. Okay, and here also, suppose for example I have here a roller support again, then both the supports are different, then it may lead to sway. Okay, then another condition is the third one, different level of supports. Now what do you mean by different level of supports? Different level of supports, it is common, you know, this is one of the most common thing that we get different levels, isn't it? Once you excavate in one pit, you will get a soft soil, so you need to go much more deeper. Suppose for example you have to go 6 feet or 7 feet, then on the other hand you get a hard stratum at just 4 feet, so you need not go at up to 7 feet or 8 feet or 6 feet. So what will happen there? The support conditions are different, isn't it? The level of support is different. Because of different levels of support, it may lead to sway. Okay. Along with that, we have different levels, right? This is a sloping road, right? We want to construct building beside that road. So the level of this support and the level of that support will be different, varying, isn't it? So this is how it looks, isn't it? See here. Suppose this is fixed, and here we have hinge, then this distance is different, this distance is different, isn't it? So because of that, frame will experience sway. Alright, so these are the conditions, these are the three conditions wherein we have to perform sway analysis. How to perform sway analysis? We'll see. How to calculate extra values or deflections, because of the loading it will get deflected, isn't it? So how to calculate that, we'll see in the problems. Okay. Right. So you can copy down this one, sway analysis. These are the three things which we generally come across for the sway analysis. Okay. Now we'll take up the problems on sway analysis. Yes. Another thing, one more thing we can say is settlement of support. One more important thing, settlement of supports or sinking of supports. Suppose this point A sinks down by 10 mm, or support D sinks down by 10 mm, 15 mm, then again the frame will experience sway. So we have to perform sway analysis in that. How to perform that, we'll see. Okay. So take down the question. Write on the question, analyze the frame shown in figure using slope deflection method and draw bending moment diagram. Okay. Now the frame is given in the question as, here it is fixed and at this location also it is fixed, and we have a point load acting at the center This is 1.5 meter. This is also 1.5 meters. And this is 8 kilonewton. We have a UDL over the horizontal span, and this is 9 kilonewton per meter, and this one is 2 meter. From here to here it is 2 meter, and till here it is 1 meter, and this is 2i and 1.5i. Okay, and this distance is given as 2 meters. So this is the frame given in the question. Okay, and we have to calculate all the end moments, that is MAB, MBA, MBC, all those moments with the help of slope deflection method. Okay, so before starting the problem, I will name this as A, B, C, D. It's very, very important. All the concepts will be in this problem. Okay, right from the beginning we have seen what are the things we have seen? Continuous beam, so many things we have seen, right? So this problem contains all those things. Okay, so very, very important. And what is the first step we do in slope deflection method? Yes, what is the first step we do? That is, we calculate fixed end moments, isn't it? How to calculate fixed end moments? So I will write here fixed end moments. So MF AB. So before that, what I will do, I will try to draw this one. This is B and this is A. Now, since the force is acting in right direction, 8 kilonewton. See, this entire frame is what? Unsymmetric frame, right? So we have to perform sway analysis. So how to perform sway analysis? We'll see in the next part. Before that, we'll solve first fixed end moments. Okay, how to calculate fixed end moments? We all know, that is, this is 8 kilonewton, this is 1.5 meter, this is also 1.5 meter. So because of this horizontal loading, the vertical member will try to get deflected in right direction. To overcome that or to support that fixed end, fixed support will create two moments. One will be an anti-clockwise moment. This is MF AB and this is MF BA. Can you tell me what is MF AB? Minus WL by 8, isn't it? So minus W is how much? 8 into 3 by 8. How much? Minus 8 kilonewton meter. Yes? No. Okay, sorry, minus 3, sorry. Minus 3, this one and this one. So what? MF BA plus WL by 8. So plus 8 into 3 by 8 plus 3 kilonewton meter. Alright, next we'll go for this span BC. What is there on span BC? Span BC has a UDL. So what we will do in for span BC? First we will fix it. We have a UDL of intensity 9 kilonewton per meter, and this is B and C. Because of this, we will be having two moments, fixed end moments. One will be in anti-clockwise and another one will be in clockwise. So what is the span here? This is 2 meter. Okay. So MF BC is equal to minus WL square by 12. So minus W is how much? 9 into L is 2 square divided by 12. Can you tell me this value? Minus 3, same. Minus 3 kilonewton meter. What about MFCB? Plus WL square by 12. So plus 9 into 2 square divided by 12, which is equal to plus 3 kilonewton meter. Okay. What about span CD? MF CD is equal to MF DC is equal to 0. Why? Because we do not have any loading on the member span CD. Suppose for example we have a UDL here. What you will do? We'll calculate fixed end moment, isn't it? If suppose it is point load or UDL, don't say it is out of syllabus. Sir has not taught us. Okay. So if suppose here you have UDL, here you have point load, we will calculate, right? You will calculate, right? I hope you all will calculate. So don't say, sir, it is out of syllabus. The entire will get full marks if once we put on the question number also. Don't say that, okay? Substitute. If suppose we have UDL here, in this particular problem, we do not have any horizontal loading on the vertical member CD. That is why MF CD and MF DC is equal to 0. Okay, right. So copy down this one. Pause. Right. So now we'll go for the next step. What is the next step we have? Next step is slope deflection equation. Before going to that, we'll see one thing, that is, see here, I'll draw here a small frame of the same frame. See here, this is our frame, right? Right? Able to see? Visible? Right. So now, because of this load of 8 kilonewton, because of unsymmetrical loading, the frame will get deflected in this direction. Yes, you all agree with this? This is how my frame will get deflected. So this is the original position. Because of this horizontal loading, the frame has deflected in right side, and that deflection is how much? Both will experience same deflection, that is delta and delta. So span AB, this is span AB, C, D. So can you tell me, AB will get deflect, CD will get deflected. What about member BC? Member BC is at same level. Okay, it is at same level, it is moving like this. Who is moving? AB and CD is moving. AB and CD is getting deflected. Deflection. Note down the word deflection. AB and CD is getting deflected, whereas BC is at same level. It is not getting deflected. Able to understand? So this is delta. So when we recall sinking of supports, we used to get extra moment, isn't it? We used to get extra moment in which direction, since the support AB, the span AB is getting deflected in a right direction. Because of the right deflection, this support will have extra anti-clockwise moment. Here also you will be having anti-clockwise moment, isn't it? Along with that, what about member CD? Here also we will be having anti-clockwise moment. Here also anti-clockwise moment. Extra moment. What is that extra moment? 6EI delta by L square. How we got 6EI delta by L square? In our equation. I will write down the equation. Okay. Now slope deflection equation. I'll write here MAB. Carefully observe here. MAB. What is the formula for MAB? MF AB plus 2EI by L into 2 theta A plus theta B, along with that minus 3 delta by L. Yes, have you seen this one? I have first mentioned this one. Once you multiply, 2 3 is a 6 EI delta by L square. Okay. So here in this sway analysis, what we are doing? We are keeping 3 delta as it is in the equation. We are not taking out minus 6 EI delta here. Okay. So here, can you tell me what about theta A here? What about theta A, theta B, theta C and theta D? Theta A is equal to 0, theta D is equal to 0, theta B and theta C is not equal to 0, isn't it? So we have to calculate theta B, theta C, and along with that we have to calculate this delta also. Okay, this delta is not given in the question. In the sinking of support problem, delta was given, isn't it? Delta 6, the support B sinks down by 10 mm, 15 mm, 20 mm, whatever it may be. But here we don't know how much deflection it is occurring. There is occurring, isn't it? So we have to calculate that. So can you tell me this MAB? What is the value of MFAB we have? Minus 3 plus 2E. What about I? What about I for this AB? 2I. Yes. Again, it is full of, calculations and observations. So once you miss anything, once you write only I here, the entire problem goes wrong. So 2I, you have to mention here 2I. What about L? What is the span of L? AB? 3. Theta A is 0. Don't say don't know. Theta A is 0. Here we'll be having theta B minus 3 delta by L. What about L? 3. Okay. Right. Now, can you solve this one? Minus 3. This is 2 2s are 4. 4 by 3. 4 into theta B. 4 EI theta B by 3. 4 by 3 is how much? 1.33 EI theta B. Yes. Am I going correct? Yes. Please correct me if I am going wrong. Okay. So what about this one? This one and this one will get cancelled. So 2 2s are 4 by 3. Again minus, right? Minus 1.33 EI delta. Don't say theta B or theta C, right? It's delta. So this is MAB. Can I name this? Can we solve further? We cannot solve further, isn't it? So we'll name this equation as equation number 1. Equation number 1. Right? Now we'll go for MBA. What is MBA? MFBA plus 2EI by L into 2 theta B plus theta A minus 3 delta by L square. Here also it will be minus 3 delta by L. So theta A will become 0, right? So what about MFBA? We have plus 3 plus 2E. I you mention here, what is I over there for span AB? BA? 2I divided by 3 into 2 theta B minus 3 delta by 3. Yes? Understand? So can you tell me this one? 3 plus 2 2s are 4, 4 2s are 8 by 3 is how much? 2.66. 2.67 EI theta B. This 3 and this 3 will get cancelled. So what will be remaining? 4 by 3. 1.33. Minus or plus? Minus 1.33 EI theta or delta? Delta. So this is MBA. Call this as equation number 2. Now we will move for span BC. Okay. Copy down. Over. So now we will move for the next member. What is the next member we have? We have completed MAB and MBA. Now we will move for MBC and MCB. So capital MBC is equal to MFBC plus 2EI by L into 2 theta B plus theta C. Here, shall I add minus 3 delta by L? No. Why? Because this B and C are at same levels. They are not sinking. Suppose span AB and span, they are getting deflected, whereas span BC is at same level. It is not getting deflected in downward direction. So I will not take minus 3 delta by L for span BC. Okay. Now what about MFBC we have? What is the value of MFBC? Minus 3? Minus 3 plus 2E. What is the value of I there for span BC? I only. Right. Correct. So what is the span of L? Span BC 2 meter into 2 theta B plus theta C. Theta B and theta C will exist. They are not equal to 0. They have some value. So minus 3 plus 2 2s are 4. 4 by 2 2. 2 EI theta B plus EI theta C. Yes. Able to follow this one? This is MBC. This is equation number 3. Alright. Now we'll move for another one, that is MCB. This is MFCB plus 2EI by L into 2 theta C plus theta B. Yes. Please concentrate here. So MFCB. What is the value of MFCB? Plus 3. Plus 2EI by L. What is the value of L? 2 into 2 theta C plus theta B. So 2 2s are 4 by 2. I will write here plus 3 plus 2 into 2 4. 4 by 2. 2EI theta C plus EI theta B. This is MCB. Equation number 4. Now we have finished span AB, MAB, MBA, MBC and MCB. Now we are left over with MCD and MDC. Okay. Right. So copy down this one. Now we will go for another equations, that is MCD. Now what about MCD? MFCD plus 2EI by L into 2 theta C plus theta D. Now see here, this span CD is again getting deflected. So because of the deflection, we will be having extra moment. How the moment will act? It will act in anti-clockwise direction. So here minus 3 delta by L. Okay. So what is the value of MFCD we have? 0. 0 plus 2E. What is the value of I we have? 1.5 I divided by L is how much? 2 meter. 2 theta D will get 0. So 2 theta C minus 3 delta by 2. Tell me the values. 2 into 1.5, 3. 3 2s are 6. 6 by 2. 6 by 2 is 3. So 3 EI theta C minus 2 into 1.5, 3. 3 into 3, 9. 9 by 4, 2.25. 2.25 EI delta. This is MCD. Equation number 5. Now MDC. What is the value of, how will you calculate MDC? MFDC plus 2EI by L into 2 theta D plus theta C, then minus 3 delta by L. Okay. So what was the value of MFDC? 0 plus 2EI. 2E. What is the value of I we have? 1.5. Then what is the value of L? 2. Theta D is 0. Theta C minus 3 delta by L is how much? 2 meter. Yes, tell me the value. Again 3 by 2. So this will be 1.5 EI theta C then minus 2 phi ei delta. Equation number 6. Okay, so far we have completed how many equations? 1 2 3 4 5 6 equations we have calculated. Now what is the next step we do? We apply boundary conditions, that is MBA plus MBC. All right. So the remaining problem will continue in the next class. Okay, thank you.